Welcome back, PHS, PreCalculus, kiddos. Section 1.1.3, we're talking about piecewise defined functions. At this point, you could probably put it into your own words, and I encourage you anytime to do so, but the definition that they offer up in the book is a function that is defined using two or more equations a function that is defined using two or more equations for different intervals of the domain. So for different intervals of the domain. So in other words, in different parts of the domain, it looks like different functions. All right, I've got two more graphs here for us to write together, and then one more for you to try by yourself. So let's try to write a piecewise defined function that each graph represents. So if we look at A, how many pieces does it look like we have? I see one piece here and one piece here. So my count over here looks like 1, 2, 3, 4. It looks like we split here at 4. So I've got f of x is equal to, I've got the piece from negative infinity and then less than 4. And then I've got a piece from 4 to infinity. So when x is greater than or equal to 4. All right, so let's try to write the equation. This is not too bad, right? This is algebra 1. It's just instead of having one line, I've got two pieces of lines. So for the first piece from negative infinity to 4, let's see, what's our slope of this guy? We're going up 1 and over 4, it looks like. So my slope is going to be 1/4 x. And then my y-intercept is here at 2. So that is that piece. The other piece is another one of these constant functions. And sometimes we forget, is that an x equals or is that a y equals? If you extend it out and see which axis it crosses, it'll tell you how to write this one. So this line, if it was extended out, would cross the y-axis at 1. So the equation for this line is y, or f of x, is equal to 1. And that's our constant function. All right, that's it for A. Let's look at B. Again, I've got two pieces to this graph. One from negative infinity to negative 3, including negative 3. And then one from negative 3 to infinity, but this time we don't include negative 3. So let's start off and change colors here. Write a little smaller. I don't know, why don't we call this one something else? How about g of x for this one? G of x has two pieces, so I need that big squiggly set bracket looking thing. So I have two lines. The first piece is when x is less than or equal to negative 3. The other piece, so I can make that a little nicer, negative 3. The other piece is when x is strictly greater than negative 3. All right, when x is less than or equal to negative 3, we've got this constant function where y is equal to negative 2. So y is equal to negative 2 when x is less than or equal to negative 3. And then when x is bigger than negative 3, we've got this function where our slope looks like down 1 and over 3. So negative 1 over 3x. Y-intercept for this guy is 1, 2, 3, plus 3. Not bad when they're nice little linear equations, right? All right, so we are now on to the you try. Go ahead and pause your video and come back when you think you've got the answer to this one. I will say for this one, I know you could probably write this one as an absolute value, but it turns out absolute value graphs can actually be written as a piecewise function. So I want you to try to write this absolute value graph looking thing. Function as a piecewise function. So break it up into two pieces. All right, hopefully you've done that. Here we go. We're going to do h of x for this one. Continue the trend. I'm going to break it up into two pieces where this is my center point. So the first piece is when x is less than or equal to 0. Or you could just say when x is less than 0. When x is less than 0, looks like my slope here is down 1, 2, and over 1. So minus 2x. And then my y-intercept would be here at negative 1. And then the other piece would be when x is greater than or equal to 0. And it looks like this time my slope is up 1, 2, 3, and over 1. So positive 3x. It also has a y-intercept of negative 1. All right, so does it matter? Did you by any chance put this piece in here instead of over here? Does it matter where the equal sign belongs? In this case, no, right? They both have this point in common. So you can attach the equal sign to the first equation or the second equation. All right, that is writing a piecewise function from our graph. We're going to do lots of matching these guys with the equation to the graph on Monday. And then the next video is going to be about evaluating piecewise functions.